When organic substances are frozen at liquid nitrogen temperatures, they undergo strange changes. These people were frozen at death. If in future they're revived, will they be the same person? If they don't remember their previous life, will they be someone else? Christopher's not been frozen, but he suffered brain damage and forgotten part of his previous life.
When I first came home, I saw the picture of me in an RAF uniform, and I didn't believe it was me, because I cannot remember wearing the RAF uniform. Up until I actually joined the Royal Air Force, it seems to be okay. And then it's a blink and blank.
The difference with Christopher now to what he was is a personality change. It's like having an entirely different boy now to what he was previously.
We had one son for 20 years, and now we've got a different one.
Scientists think that what we learn and therefore memorize is stored in different parts of our brain, but in particular in a small area called the hippocampus. The hippocampus contains brain cells called neurons. Each neuron has a tree-like structure with many branches. Along these branches there are places where one neuron seems to touch another. In fact, there's a very small gap between them. At the gap, electrical signals burst little bubbles filled with chemicals which cross the gap and set up an electrical signal in the other neuron. Dr. John Larson believes that our memories are stored around these gaps. In his experiments, he's taught this rat to remember certain smells.
Lemon versus strawberry.
Strawberry and lemon odours come out of two holes. The rat has learnt that if it sticks its nose into the strawberry hole, it will be rewarded with water. To find out what's going on inside the rat's brain while it's learning, John's recorded its brain waves.
On the oscilloscope here, we can see the brain activity as the animal is actively sniffing an odor. You can see repeated waves of activity at about 5 per second. This is the magic rhythm of the brain that's used to, we think, store memories.
Ideally, he would like to look inside the rat's brain before and after it's learnt the trick. But since that's not possible, he takes slices of brain from an untrained rat and prepares to stimulate them with the magic 5 cycles per second learning rhythm. It's the closest he can get to teaching the brain slices the strawberry trick.
Now, I'm going to activate the cells at 5 hertz. So here it goes. Now, if we compare the response before with the size of the response afterwards, you see that there's been a large increase in the strength of the connection between the two cells.
John thinks that after stimulating the rat slices with the magic learning pattern, the connection between the brain cells is strengthened and memories are stored here. Using an electron microscope to magnify the brain slices 75,000 times, they can see changes in shape around the gap. This is the shape of a section on the receiving end of the gap before stimulation. And this shows the shape of a similar section after stimulation. If John is right, every time you learn something, your brain changes shape. It's as if our memories are held in these chain structures in the brain. But does this mean that if people were brought back from the deep freeze, they would still have their memories?
If the other functions of the brain, its sensory functions, thought processes, were to survive intact, there's no necessary reason to think that memories would be lost.